Lesson 4.6, Solving a Quadratic Equation, Examples 1 and 2. Looking at the quadratic equation in front of us, we can see that we have an x squared component, and we also have two constant terms, but there is no middle bx term. Therefore, the easiest method to use will be square rooting. The first thing we want to do in this case is subtract 11 from both sides. When we do that, we have 2x squared equals negative 48. From here, we divide both sides by 2, continuing to isolate the x squared. And we have x squared equals negative 24. Before this lesson, when we would square root both sides, we would notice that there's a negative underneath the radical. Up until we learned about imaginary numbers, this posed a problem. But now that we know that we can simply pull out the imaginary number and keep that root 24, we can continue with the problem. We still need to simplify square root 24, so I can write that as plus or minus I root 4 times root 6, which would give us plus or minus 2I, writing the coefficient in front of the I, root 6. I now know that my two solutions are imaginary, which means they would not show up on the real coordinate plane if I graphed this equation. Moving down to number 2, same principle. We're going to start by subtracting 18 from both sides. That gives us 2x squared equals negative 90. Divide both sides by 2. X squared equals negative 45. I know I can handle real or imaginary solutions, so I can keep going. Square root both sides. X equals plus or minus I root 45. I can continue to simplify root 45. X equals plus or minus 3I root 5. Two solutions, again, both are imaginary. I'd like you to go ahead and try the guided practice on page 275, 1 through 6. And I will give you the answers ahead of time so you can check them as you go. The answer to number 1 should be plus or minus I root 13. Number 2, plus or minus I root 38. Number 3, plus or minus 2I root 2. Number 4, plus or minus 2I root 7. Number 5, plus or minus 2I root 2. And number 6, plus or minus I root 6.